So welcome everyone. Today I'm going to talk about Kotlin's ecosystem at the backend side. So first an introduction about myself. Well, Wouter gave it all away, but some small information here. You can follow me on Twitter under this Twitter handle at Paulien van Alst. I'm a software engineer at OpenValue. I'm from the Netherlands obviously, and I'm a co-host at the Barcoding podcast. You can find us on Twitter under this very confusing Twitter handle, coding_bar, where you can follow us on our new episodes that are released monthly and talking about software engineering. I'm in love with programming, so luckily I can do that all day because that's all I want to do actually. And as Wouter said, I'm a Google developer expert in Kotlin. So what are we going to talk about today? Well, today I'm going to convince you that working with Kotlin at the backend side is a very good choice to make, and that there are some things that you should keep in mind about the choices you have to make. Kotlin is not only a programming language for mobile development, but is also very, very suitable at the backend side. And it's not only about Kotlin, but also about its whole ecosystem around it, which is growing very fast actually. So why should we even build a backend then in Kotlin? Otherwise it's really awesome actually. And I'm coming from Java, so I will also try to talk a bit about the perspective about working with Kotlin when you're coming from Java. And where to choose from. There's a lot to choose from in the ecosystem. It's not only about the language, but there's a whole ecosystem around it. So when you're going to work at the backend side with Kotlin, you need to think about your application framework, your HTTP libraries, for instance, because we are doing a lot of communication through HTTP. Dependency injection, if you want to use it, you don't necessarily need to, but if you want to, you can have a thought about that as well. And of course, database libraries. We're working nowadays lots with data, and a lot of our applications at the backend side are using database libraries, so this is an important thing to think about. So why even build backend in Kotlin? Well, Kotlin has its advantages, of course. It's a pretty upcoming language at the JVM side. It has its advantages like they want to focus on readability, on maintainability of your code. So if you compare it to Java, for instance, it will have less boilerplate code. And I think those are very major advantages to work with Kotlin actually. Concurrent programming, of course. Kotlin coroutines are, I think, a very powerful feature in the Kotlin language, which you can't really find in other JVM languages. So if you have any requirements regarding that part, have a look at Kotlin coroutines, of course. Lightweight applications, not only at runtime, but also lightweight in complexity of your code base, as a lot of Kotlin language features are enabling you to write readable and therefore maintainable code. And of course the use of domain-specific languages, DSLs. DSLs enables us to express ourselves in a more human-readable way. Our job is to make complex things simple, and sometimes DSL can help with that. So I think DSLs are also a very good argument to have a look at Kotlin if you're developing at the backend side. So there we go, challenges when we're coming from Java. We'll assume during this talk that we all have some preferences or coming from Java. So first thing to keep in mind is that Java libraries and frameworks are using reflection, and sometimes this doesn't really go along with Kotlin wanting everything to be immutable. So this is something that can feel awkward sometimes when you're working with Kotlin in the Java ecosystem. Some frameworks are also proxying classes, and this doesn't also feel really natural when you're working with Kotlin, as Kotlin wants their classes to be final and therefore non-extensible. So this can feel awkward as well. Nullability, of course. Kotlin doesn't really like nullability as well. You can define your types to be nullable or not. Java libraries and frameworks, of course, will have nullable types everywhere. So that means that you need to do some tricks to don't have to deal with that nullability of Java everywhere. So those are challenges if you're working with Kotlin in the Java ecosystem. If you want to have full power of Kotlin, you should have a look at the Kotlin ecosystem as well. So, where to choose from? Dependency injection is one of the topics that you want to have a look at. Database libraries for your communication with the database, HTTP libraries, and application frameworks. So dependency injections, there are, I guess, in my opinion, 3 big players on the market. If you start Googling about dependency injection in Kotlin, you will find DAGGER. DAGGER is widely used in Android development, and therefore you will find it in combination with Kotlin. And then there is KOIN, which is a very good candidate as well, and which is completely written in Kotlin and written for Kotlin. And then last but not least, the big market leader actually in the industry, and that's Spring. I will talk a lot about Spring, and there's a reason why. It's not only focusing on Java Spring, but Spring is also focusing on Kotlin. So Spring is becoming a part of the Kotlin ecosystem. So DAGGER, if you have a look at DAGGER, you will see that it's borrowing a lot from the Java EE annotations. You will recognize a lot there because it's relying on Java EE. DAGGER will do some code generation during compile time and will resolve its annotation in that way. And you will have some compile options to speed up your compilation and stuff like that. So that will take a while. I haven't worked with it, but I think it's a player to mention here, so that's why I'm mentioning it here right now. Then let's have a look at KOIN. KOIN is written, as I said, in Kotlin. It uses interfaces, which enables you to choose your implementation strategy, which implementation of your bean you want to use, of course. You can organize your beans in modules, which also means that you can change the implementation of your bean depending on the module wherein you're declaring it. So that's pretty powerful. And of course it knows the scope that we are used to when working with dependency injection, such as single, factory, or scoped. So let's have a look at the code, how our code will look like if we're using KOIN, for instance. So in this example, we will have a recipe service, which is depending on the recipe repository, both being beans. In this example, I don't use any annotations whatsoever. I can just declare my class with its dependency, the recipe repository, just in this way. This is fine. And then the bean configuration, I will do that in the code where I boot my application. It will look like this, where I will declare a recipe module, which will be created at the start of the application. I'm in control when the module will be started, and where I can declare a single recipe repository, which will be injected in the recipe service like this. Then, of course, I want to use my recipe service in my endpoint, for instance. In this endpoint, I will insert some recipes for cake, for instance, and therefore I can use the by inject syntax of KOIN. So it's pretty declarative and not annotation based that we might be used to coming from Java. Now have a look at Spring. You will recognize there some stuff. Spring is hopping on the Kotlin train as well, so it's a valuable player in the market. Spring is completely annotation based. Spring beans are not final, so that clashes with the fact that Kotlin classes are final by default. And I mention it here as being testable. By testable, I mean that a lot of testing frameworks are assuming you're using Spring and will then integrate pretty well with Spring as well. So using dependency injections and starting up your application will look like this with Spring, where you will declare some annotations over your class, just like this, where component will be declared with the @component annotation, and where I need to declare my class as being open. I can here use compiler plugins with Maven, for instance, where all the classes annotated with a Spring annotation will be declared open under the hood. I like my code to be explicit, so that's why I would advise to declare my class like this. With Spring you can also declare beans as interfaces, like this example with a repository. Well, then HTTP libraries. We're doing a lot of communication with through HTTP, and there are some really nice lightweight Kotlin, pure Kotlin frameworks actually in libraries. So HTTP 4K is the first one. KTOR being one of the application frameworks candidates, will have its own HTTP client, and of course there's the Spring REST template. So let's have a look at those. HTTP 4K. Well, HTTP 4K is a very lightweight library that you can integrate pretty easily into your application, also side by side with Spring, for instance. It's full Kotlin, and it has some really powerful features as it is using all the language features from Kotlin as well, such as a DSL and stuff like that. So it's much more declarative. So this is an example of a HTTP client where I can just write down like I'm a client and I'm putting a request in it and it will return a response. But as you can see, and I can build up my request pretty easily, and I can just inject my client in my my functional class like this. The KTOR HTTP client will comes along with KTOR, of course, so you don't need, if you're building a KTOR application, you don't need to add some extra dependencies for your HTTP client. It's full Kotlin as well, and there it will look a bit more like a DSL, where you can declare your request being built up like in this example, where I can just declare my method to be a get, for instance, and where I can use some useful methods like check if my status is successful. So I don't need to check, for instance, on a very specific status, but I have some useful methods there. Then have a look at the Spring HTTP client. This is a classic one. It integrates with the rest of Spring, of course. It's pretty solid in the deserialization of a request or responses, or serialization. And it will look like this, where you need to declare a bean, which is a REST template, and where I can use the classic method call to do my get request in this example. So that was about the HTTP libraries. Now have a look at the database libraries. Database libraries, there's also some really awesome stuff going on. For instance, Exposed from JetBrains, which is full Kotlin. Joke, I think it's called. It's a Java ORM, but also hopping along with the Kotlin train, and Spring, of course. Some points of attention if you're looking at database libraries. You need to have a look if it's a full Kotlin database library, if the DSL is suitable for your needs, because depending on the queries you want to write, you need to be able to express yourself in your code. And if you're using coroutines, make sure that the library itself is also supporting coroutines and being reactive or asynchronous, for instance. Otherwise your coroutine will be blocking on your database call. So first have a look at Exposed. Well, it's a DSL, as it is written with all Kotlin, so you will have a more natural way to express yourself. It's supporting lots of database dialects, Postgres, MySQL, Oracle, but lots more. Those are all supported. So let's have a look at code with exposed. You can, for instance, start with your method where you initialize your database. In this example, I'm connecting to the database with Hickory, and then I'm starting to build up my database using the create function in the schema utils. Of course, I can still use flyway and omit this part that exposed is proposing to me. Flyway having the advantage that you have a full audit log of your database mutations. I have a look at the code that I will have in my repository then. With exposed, I will be able to declare my table, my recipe table, as in the lowest example, where I can describe how my table is called, what are the columns, which types do they have, and then I can describe every row in that column, or in that table, I mean every row, and describe how my fields are mapped to the columns in my table. Then in my repository class you will see that I can declare a transaction and then just insert a row, for example, in my table, just like this. Or retrieve any row compliant to the expression that I have here in my find statement, using words such as egg to find any recipe having a name equal to the name that I'm looking for. This is pretty cool, of course. I find it a pretty declarative way to write down my queries. Then have a look at joke. Joke is from the Java world, but also hopping on Kotlin. It has a full Kotlin integration, but they're not really declaring a DSL for your database queries. It's more a chain of functions calling themselves. Then of course there's Spring. Spring will be a full annotation base where I can declare a data class. That's fine, having a table annotation, and I can declare my repository just like this, declaring my query in the annotation query. What's awesome with Spring is that Spring is also hopping on the coroutine train, so you can declare, like in this example, a coroutine thread repository where my return type will be a flow. So in that regard, my whole database call will be non-blocking here. And now the application frameworks. You can go full Kotlin there as well, so you don't need to remain in the Java world for that. I can have a look at KTOR if I'm building my application in full Kotlin. I can have a look at HTTP4K. HTTP4K is not only being a HTTP client, but you can also build your own HTTP server in HTTP4K. MICRONAUT and Quarkus, of course. I hope I won't harm anyone by putting and Quarkus between quotes here. But both are equivalent regarding adopting Kotlin. GraphQL, of course, there are options to build your GraphQL service API in Kotlin, and of course Spring. Let's have a look at KTOR. KTOR is a lightweight application framework, all written in Kotlin. It has some configuration which is very declarative using a DSL. It can only be used with Kotlin, so you can't really use that thing with hybrid solutions. It supports WebSockets, for if you want to have some reactive programming there. So, let's have a look at how KTOR looks like. You can declare your application like in the first example, where I have my main function where I can initialize my database, start up my Netty server in this example, and using extension function on the class application, I can declare some configuration. In this example, I'm specifying that I have some content negotiation with Jackson and that I have some endpoints in this application declared. An endpoint can be declared just like this, where I have can use the route block, wherein I can declare all my routes that I have are under a certain URL. Now let's have a look at HTTP4K. Again, it's pretty lightweight. Configuration with DSL again. Only be used with Kotlin as well. And WebSockets, and it has a GraphQL module as well. What's great with HTTP4K is that it also supports serverless backends. So you can really declare your HTTP server being just a function, and then do your serverless magic there. So let's have a look at how a simple endpoint in HTTP4K will look like. You can just declare a function describing your request and which response it will return, and also using the DSL from HTTP4K. So this is a very simple example. Of course, you can go a bit more complicated there. So here is how I declare the response and how I do the request. If you are using multiple routes, you can declare it like this using the routes function, where you bind your URLs to certain methods like a get or delete in this example, and where I can of course declare my path parameters, which I can then retrieve in the way that is listed here in this example. So yeah, MICRONAUT. Everything I tell here about MICRONAUT is also suitable for Quarkus, as they are following the Kotlin adoption side by side in the same ways. You can declare your functions using Kotlin. It's running on a Graal VM in the same way, and MICRONAUT has a CLI which is pretty awesome, where you can initialize your applications or functions using your command line tool. Code will just look like this. It's pretty much the same as you will have in Java, where you will be using nullable types though. And have a look at Spring. As I said, Spring is also looking at Kotlin, and therefore a candidate in the Kotlin ecosystem. Using Spring Webflux and coroutines, you can go full reactive there. The Spring is of course an industry standard, which can be a valid argument to choose it. And it's approaching Kotlin more and more. I can't stop repeating it actually, because it's really true. They're really developing and having a look at Kotlin there. Spring will then rely heavily on their annotations, and just like this code example. And as I already mentioned during the database library part, you will be able to have those awesome coroutine thread repositories. Now have a look at GraphQL. HTTP4K has a GraphQL module, so you can have a look at your HTTP4K server and then maybe integrate GraphQL with it easily. The Expedia group also developed HTTP4K framework, which is fully developed in Kotlin. I just did that a few weeks ago, and it's pretty awesome. So to summarize, what you can do in a Kotlin ecosystem, well, we have a lot to choose from. Still, if you're choosing to go full Kotlin, your code bases will change. It won't look like your Java code base for sure. The look and feel will be different, and the maintenance as well. But I would say just one thing, and that's to embrace the Kotlin ecosystem. That was my talk. Thank you all for listening.
Awesome. Thank you, Paulien. Great talk. We don't have a lot of questions in the chat, but while I was listening, I also have some questions. So during my day job, I use primarily Java, but also Kotlin. And sometimes we have this discussion, is Kotlin mature enough? Because Java has been going on for 25 years, 26, 27, I lost count?
27, yeah.
27, a lot. And Java is relatively new to the party.
Kotlin.
Kotlin is relatively new to the party. Is it mature enough?
Well, it depends on, of course, on what you mean by mature enough. It won't never ever have the same maturity level of Java, as it has it's lacking 20 years of experience, of course, but I think that's why I made this talk, because we're always talking about the language Kotlin, but there's an ecosystem developing itself around Kotlin, which is not only developed by JetBrains. In my talk I'm talking about Exposed, which has been developed by JetBrains, and also about KTOR, which has been developed in JetBrains. But HTTP4K is coming from the community. KOIN is coming not from JetBrains as well. If you see that Expedia is also developing their GraphQL framework in Kotlin as well, which is still Java under the hood, but still, I think this means that the maturity of Kotlin is growing, and it's maybe not mature enough in that regard. Everyone in every situation can use it, but it's certainly mature enough to be used in production and to be adopted by the industry.
Cool. We got some questions in the chat. Roy was asking about if you have looked at Kotlin native, and also the question about is that mature?
Kotlin native? Is that mature? I think Kotlin native is becoming more and more mature, but I think it's depending on the project you're using. It's good to experiment with. It's good to have some really great proof of concepts, of even bring something to production with it. But you should be really careful about it, because it still needs to grow.
Yeah.
Yeah.
Yeah. So Java, since a number of years, has updated their release cadence.
Yeah.
Previously it took years and years and years,
yeah.
And now on the dot every half year. And Ali is asking, is Kotlin still a good choice with Java's faster update cadence, or is there some friction?
No, there's no friction. You can use both of the languages in the same application. That's the friction question. But yes, if you want to go for Java, Java is a suitable choice. It has a enhanced release cadence right now. You need to do some choices about which release you want to use, of course. But the Kotlin release cadence is still faster, and Kotlin is still developing faster. They can do it because they're younger, of course, so it's easier to go faster. But I think Kotlin has really valid arguments to go faster, and it has really nice advantages.
And I also read that Kotlin is basically enjoying the features that are now built for Java or the JVM, but they're also integrating with, for instance, now with record classes, which then are compatible with Kotlin data classes.
Data classes, yeah. So I think for both languages, looking at each other and triggering each other to become better is really cool. But I think there's still two different languages with both their needs.
Okay. Roy was just asking, how fast is the Kotlin cadence? Do you know? Is there a structure?
The minor releases, the patch releases and minor releases are every now and then. And I think the patch releases, the minor releases once a year, I think so. So they released 1.4, I think, 18 months ago, something like that, and on 1.5 was released a few months ago. Yeah, so it's going pretty fast.
And I do know of another formerly popular Java or a JVM language that rose in popularity, but then descended quite quickly. Yeah. I'm referring to Scala, of course. Yeah. Will Kotlin follow the same fate?
No.
Or not?
No. I don't think so. I think Scala was a great language, and Scala was responding then to the needs of functional programming. We all wanted to do functional programming, and Java was not enabling us. But Scala was way too difficult for us as simple software engineers. And I think that was the pitfall of Scala. Not only that, Scala had its own build tool, which was taking much too long to compile anything. Kotlin didn't develop their own build tool. They're integrating with Maven, they're integrating with Gradle. Kotlin has some powerful language feature, but not that powerful that we lose ourselves in it.
Yeah.
So, and Kotlin is not developed at the university, but in the industry by people using it. And I think that's the power of Kotlin.
Yeah, Scala had a number of tools to really shoot yourself in the foot.
Yeah, and that hurts.
And that hurts really bad. Kotlin less so. One final question. There's another question. What day-to-day benefit does Kotlin give you over Java in terms of cleaner code?
You mean the Kotlin features then? Cleaner code?
Yeah, I guess so. So I think in general, what does Kotlin bring to allow you to write cleaner code if you compare it to Java?
Yeah, I think that's a very important question that everyone should ask themselves when they start writing their code in Kotlin, because it's really easy to write Java code in Kotlin without really writing pure Kotlin code. I think the non-nullable types will enable you to write cleaner code. Type aliases will help you as well. Operator overloading can help you if you're doing lots of calculation in your code base. And I do think that extension functions to declare behavior on collection level will definitely help your code base to be more readable, but also more maintainable.
Cool. And one final question. Will there be a Kotlin special on the Barcoding podcast?
A Kotlin special on the Barcoding podcast? If Arnoud wants to do that, there will definitely be a special about Kotlin. Yeah.
Awesome. Thanks so much, Paulien.
Thank you.